All right, welcome. Today, we are diving into a really fascinating question that could completely reshape how we build and train AI. By the end of this, you're going to understand a groundbreaking new way to teach an AI how to think instead of just how to Google.
So, let's start with this. What if an AI could tap into that huge universe of knowledge that's already packed inside its own network, without having to constantly go look things up? And this isn't just some sci-fi thought experiment. It's the real idea behind new research that teaches AI a skill that looks a lot like human introspection.
Okay, so here's the crucial difference. Right now, most AI agents rely on tools like search engines, and that process can be really slow and pretty expensive, because every single question is what's called an API call to the outside world. It's kind of like a researcher having to literally run to the library for every single fact they need. This new idea, internal search, is totally different. It's like that same researcher has already read the entire library and just needs a quiet moment to think and access that memory.
Now, to really get why this internal approach is such a potential game changer, we first need to take a quick look at the current and pretty costly habit that most AIs have. So, the gold standard for a while has been a technique called reinforcement learning with search. Basically, you give an AI a problem and you reward it for getting closer to the right answer by using a search engine. It learns through trial and error. But the catch is, every single one of those trials costs time and money because it depends on that external tool.
So researchers asked a pretty brilliant question. Can we get the same results, or maybe even better results, by training the AI to look inward instead of outward? And this is where this new concept of self-search comes into play.
So, self-search is a method where a large language model, an LLM, basically acts as its own search engine. When it hits a wall and needs information, it doesn't call out to Google or Bing. Nope. Instead, it formulates a query for itself and then generates an answer using the knowledge it already has stored away. The entire conversation happens internally.
And this whole approach is built on a really powerful belief that these big language models already contain just vast amounts of world knowledge. The real challenge isn't about cramming more information into them, but about teaching them how to find and use what they already know in a smart way. And the results of this are, well, they're pretty mind-blowing. Check this out. On one tough question answering task, a huge 70 billion parameter model got about 81% accuracy. But a model nearly 10 times smaller reached basically the same level of performance. So what was the secret? Giving it more thinking time, or in technical terms, letting it generate more samples. This really suggests that the right technique can unlock some seriously impressive performance, even from smaller, much more efficient models.
Okay, so how on earth do you actually train an AI to develop this inner voice? Well, the method is called self-search reinforcement learning, or SSRL for short. Let's break down how it works.
The training is all about forcing the model to follow a very structured reasoning process. First, it analyzes the problem. It thinks. Then, if it realizes it's missing a piece of the puzzle, it formulates a question for itself. It searches. And finally, it generates the information to answer its own query. And it can go through this think, search, information loop as many times as it needs until it's confident it has the final answer.
And here's a really clever part of the training. The AI doesn't just get a reward for getting the final answer right. It also gets a specific format reward, just for correctly following that think, search, information structure. It's kind of like a math teacher telling you, hey, it's not just about the answer. You have to show your work. It forces the AI to develop good mental habits.
The researchers also added another brilliant twist called information masking. So during training, after the model generates the information for itself, that information gets hidden from the model for the next step of its calculation. This prevents the model from getting lazy and just copying its own answer. It actually forces it to reason more deeply, which leads to much more robust and genuine problem-solving skills.
Okay, so the training method is really smart, but does all this internal simulated training actually work? How does it stack up against methods that use real-world tools? Well, the results are pretty darn clear.
When you compare it on several different benchmarks, the SSRL method consistently comes out ahead. A model using a real external search engine scored about 40.4. Another method using a simulated search scored a little higher, at 41.5. But the SSRL model, the one that just talks to itself, actually outperformed both of them with a score of 43.1. That's a strong sign that training a model to access its internal knowledge can be even more effective than training it to use outside tools.
And on top of the performance, this method is also way more efficient. Training a model with SSRL is over 5 times faster than the previous best simulation method. That huge gain in efficiency could make it much more practical to train really powerful AI agents in the future.
Now here's another key finding, something the researchers call sim-to-real generalization. This is a huge deal. It's the idea that the reasoning skills an AI learns in a completely simulated world can be transferred directly to solve problems in the real world.
Let's break that down. During training, everything is 100% simulated. The model is learning how to think, how to structure its questions, and how to reason its way to an answer. Then later, when it's actually being used, you can plug in a real search engine. And because it's already learned the process of structured thinking, it knows exactly how to use that real tool effectively, with no extra training needed. And this enables a really smart hybrid approach. Using a technique called Entropy-Guided search, the model can decide for itself when to rely on its internal knowledge and when it's better to use an external tool. It basically measures its own uncertainty. You can think of entropy as a measure of randomness or confusion in its own thoughts. If that uncertainty gets too high, it knows it needs help and makes that external call. This simple trick reduces those costly API calls by up to 42%, all while keeping performance high.
So, let's zoom out. What's the big picture here? What does all this really mean for the future of AI? Well, this inward turn, this focus on self-search, it has some pretty profound implications.
So, what should you take away from all this? First, these big language models have massive amounts of knowledge locked away inside them that we're only just now learning how to access. Second, training an AI to structure its thinking might actually help reduce factual errors, or what we call hallucinations. And third, skills learned entirely in simulation can actually transfer to the real world. Now, it's really important to remember the limitations here. This method depends on the knowledge that's already in the model, which can be outdated or incomplete. So it's a powerful tool for sure, but it's not a replacement for external fact-checking when the truth really matters.
And that leaves us with a final, big question to think about. If an AI can learn to search its own mind, what's the next human skill it could learn to simulate? Creativity? Intuition? Maybe even some form of self-awareness? I'm curious what you think is the most likely or maybe the most concerning next step. Let us know your thoughts in the comments.